All right, so what we're intending to do here is to build up a body of knowledge, and one of the things that we'll look at is linear implies a couple of things, the point slope equation, but we can have it in this form. Okay, y equals mx plus b, so that's our linear equation. That's the gradient, the coefficient, that's called a gradient. This one here is called the y-intercept, that's where it cuts the y-axis. For graphs of a different type, it is possible to do this kind of thing, to put it into this kind of form. That's a general form of a linear equation. Okay, sometimes we have to rearrange it into this gradient intercept form to help us process it. Now, what I want to do is talk to you about an algebraic and geometric. And in fact, that's so important that I'm going to put it in our strategic intent. Because we're only doing it here for linears, but we can do it everywhere. So I'm going to put it down here as algebraic and geometric interpretation. And so we need all of this information. Now, it seems like a lot, I know. All right, so the idea here is that if I, now I'm going to do the arm thing. So I think what I'm going to do is add a little camera. And so I'm going to do that. See how that comes up. That's good. Okay, so that's fine. Where is it? Okay. Sorry about that, just a little delay while I sort this out. Maybe not. Okay. That's all right. I can do it this way. Okay, whoops. Very interesting. No, I think I'm just going to have to get off this for the moment. Doesn't seem to want to show me what I want it to show. So I won't spend any more time on it. Okay, interesting. All right, sorry about that. So the geometric interpretation. So what we'll have is we'll have our sorry, I've just let's see. So our basic idea here is that we have one like this. It's about halfway, same angle, one way and then the other. So I might just change that, just so I can make that look a bit more regular. So just about halfway, that's better. So that's our y equals x. Now in all things, we like to use our arms to explain that. So we have our vertical arm and we go flat and up again. And it's interesting, isn't it, that although we can see the expression, it's hard to cognate that it's actually got a number in front of the x and a gradient or y-intercept. So that's 0, 0 down there, and this line is cutting that at 0, 0. Okay, so we can use our intuition to develop a graph and its algebra. So what about if we move this up? What about if I move that up and made it like that to 1? What would the algebra be in that case? So the algebra would be y equals still 1x, so it's x, but now it's been shifted up 1, so we've got now a shifter. Okay, it's called dilations and translations back in school land. For this one here, y is still equal to 1x, but the shifter now is minus 1. So look at the algebra that we're generating fairly easily. And of course, this comes with the idea that there'll be zeros somewhere else. Okay. So what about if we want to have it steeper? So we can go for twice as steep. So if that's our general one, go for twice as steep. So y would be equal to 2x plus 0. Okay. So for shifted up, twice as steep. Okay, twice as steep at 2. So we would get y is twice as steep at 2. And twice as steep down here at minus 3. It's still twice as steep, but we've got y equals 2x, but shifted down. Okay, so these are general ideas. They're very, very straightforward. Our table of 9 of these things will give us the what about if it's half as steep? Is our benchmark? What about if it's half as steep? It's interesting. So can you write down what the equation is? Half as steep. Okay. So y equals half of 1. Still going through the origin. For this one here, we'll make it come up a little bit at 2. So y is half as steep, but it's been shifted up. For this one here, it's been shifted down to minus 1. So we've got y equals half as steep at minus 1. So look at all the equations we're generating. It's quite amazing, isn't it? So we've got steep, less steep, the same, generating all of this. So what happens then if we go ahead and change direction? What about if we change direction? I'll pick a different pen here. So this time, instead of going left to right, we'll go right to left. Is it the steepness the same? Is it just as hard to walk up here okay, as it is to walk up here? And the answer, of course, is yes. Okay, so the steepness is the same. That means the gradient will be the same. So how do we account for the change in direction? Another piece of information. Oh, now minus is doing something else. Minus is like a spy that goes around and changes its habits and changes its colour and its shape. It's a chameleon. It gives off different information. So it's telling us this. What about this one here? Same gradient. Okay, same gradient, but this time shift up. So y equals negative direction, still 1, but now we're shifted up. Okay, so very straightforward. This one here, I don't know why they don't spend more time building this kind of thing up at school. And minus x minus 1. Oh, look at the interesting algebra we're getting. So there's lots of ideas there in terms of algebra. Twice as steep, other direction. Okay, so now it's steeper, but it's the other direction. So that's the direction information, that's the steepness information, and that's our variable. This one here, still twice as steep, but y is now equal to the other direction and shifted up to 2. So this one here, shifted down to -3. Opposite direction, twice as steep, -3. Look at the difference in the algebra. Okay, very, very interesting. For this one here, half, and so y is equal to negative, change of direction. For this one here, half, so y is equal to -half x plus 2. And for this one here, y is equal to -1/2 x minus 1. So we've got lots and lots of different ideas here. So one of the things we'll be looking at for this week is solutions as well. So we'll spend a bit of time looking at that and trying to understand our solutions. All right, so for our solutions, if we think about what is a solution, okay, a solution of an equation of equations, we can call it the x-intercept, where it cuts the x-axis. The solution of the equations is where it cuts the x-intercept, and also we can call it the roots of the polynomial. So a solution or a root, it's a similar thing. In our case, our polynomials are very straightforward. So the roots of the polynomial. So here, the value that makes this true when y is 0, y is positive infinity up here and negative infinity this way, and in the middle here it's 0. Okay, so y is 0. What makes y equal 0? X is 0. So the solution is x is 0. For this one over here, it's a bit tricky depending on which one you're doing. Now you will have seen this written in another way, so I'm going to take these off and just do them this way. So we have y equals x plus 1. You can think about the geometry of that. And I want you to think about what you may have seen at school. They're linked. That solve is a particular case when y is 0. So in other words, when y is 0, this is cutting the axis. So it's asking us for this value here. Okay? These are all the same. All we're doing is asking for the x value. Okay, what's the x value? We know that one. What's the x value? What's the x value? They are the solutions of these particular equations. Okay, they're question mark. Okay, same here, x is 0. What are the solutions? What are the solutions? Okay. So what are the solutions? It's very important that you gravitate your understanding geometrically just as much as what you've learned in your equations. Now, what's the operator between the x and the 1? The operator between the x and the 1 is a plus. So how do we undo a plus? Now, I'm being very deliberate for a particular reason. How do we undo a plus? Well, we subtract it. What we do to one side, you do to the other. So this becomes x is equal to -1. So that is the solution of this equation. There it is there. Negative x is equal to -1 is the solution. Now, we can check that by using our function notation, which we did talk about a little, but certainly it was in the notes, in the video that went with the notes. So we're going to check y minus 1 using function notation. So we're looking at this equation here, okay? So I've got -1 plus 1 is equal to 0. And so therefore is a solution. So this basic idea that we have solutions. If the original equation gets the value put in it, that's the x, okay? Then what we'll have is a solution. All right, so what I'll do is I'll just press pause there, and I'll be back soon.